Welcome back, and in this video we're going to start with problem number 9, which is without a calculator, sketch a graph of a power function and their translations. Find the domains and range and write a statement that describes the end behavior of a power function. So we're going to start with that one. We have 5 and 6 here. That's power function x to the third on this one. So you should know how to graph x to the third. It's one of those ones that you have memorized. So 0, 0 is on that x to the third. So 0, 0, 1 to the third is 1. 2 to the third is 8. 2, 4, 6, 8. So it goes up and through this point. 2, 8. And 1, 1. Also does the same on the opposite side. So it does negative 1 and negative 8, 2, 4, 6, 8. So right here drops down to there at negative 2, negative 8. Okay, so that's x to the third. This is just going to shift it to the left 2 units. So we're going to take this function, move it to the right, to the left 2. So it's going to go here, it's going to go here, it's going to go here for these points, and then the other points are also going to do the same thing, to the left 2, to the left 2. So our graph would be like this. All right. That would be your stages. Just 2 stages there. All right, on this one we have x to the fourth. So that's going to look like a parabola. It's going to look like a squared one, just a little sharper. So 0, 0, 1, 1. But in 2, when you raise 2 to the fourth, you're going to get that 2 times 2, which is 4. So you're going to go, so 2 to the fourth power is 16. So it's way up here past this point. It's a really steep upward graph. And that happens on both sides. Negative 2 is also the same thing up there. It's a very steep upward graph. So this does a right 1, shift, and a reflect. All right, so right 1 and reflect. The graph should look like this. You move it over to here. It reflects, so it goes down instead of up. And then down to 16 here, which is huge, way down here to the 16th. And so it's steep, very steep going down, and steep going down here. All right, so that's what happens there. It moves right 1 and then reflects. Now, so as x goes to infinity here, f of x goes to negative infinity. That's its, and same thing with x going to negative infinity. F of x goes to negative infinity again, because both sides are going to negative infinity. This is going to negative infinity as it goes right, and as it goes left, it's going to negative infinity. This one, as it goes right, it goes to positive infinity, and this one, as it goes left, goes to negative infinity. Okay. All right. The next thing it says, here's our cubic. So this is like a cubic. So the domain is all real numbers, and the range is all real numbers, or negative infinity to positive infinity. Now, if it's an even powered one, then your range is going to be restricted. So the range on this one is 0 to actually we would have to write it with negative infinity first because it's smaller there. So it would be negative infinity to 0 would be its range for this problem. Domain on any power function is all real numbers. Okay, the end behavior here, since it's positive and going up, and it's negative. It says it's negative, so it means it's going down. So this graph actually looks like this. So as it goes to the right, this should be negative infinity because it's going down here. But as it goes to the left to negative infinity, it's going to go to positive infinity. Okay, so that's section 9. Section 10, you're going to combine some power functions into polynomial functions so that it causes the power functions to wave in the middle. So this tells me what's the lead term of the polynomial. So the lead term is 4x to the 5th. And the constant term is negative 30. It's the one that has no x in it. So the constant term on a graph would tell you where it crosses the y-axis. So this is the crossing, this is the y-intercept of the graph. So if you have the constant term, you know where it crosses the y-intercept. At most, how many zeros does it have? So that would be the power. So it has most 5 zeros. And if it has 5 zeros, it can only have 4 turning points. It can turn 4 times if it has 5 zeros. Which of the following graphs is a possibility? So it's odd. So that means it has to look like this up here. It goes up and down. So it can't be this one because this is even. And it can't be this one because it's even. All right, so it has to look like this. So if we're looking for 5 zeros, 1, 2, 3, 4 turning points. This only has zeros. Okay, so we're looking for turning points here. 4. There's 1, 2, 3, 4. There's 4 here. 1, 2, 3, 4. So it's either one of these two. It's not this one. This has too many turning points. Here's 1 turning point, 2 turning points, 4, 5, 6. This has 6 turning points. So this is not it. It's one of these. Now, since the lead term is positive, that means it has to increase overall. So that means it's this one. Because this is increasing most of the time, except for the little waves. This is going down as it goes to the right. So it's letter I because of that. Now, remember, it has to cross at 30 or negative 30. So when you're doing this, when you're graphing this, you have to make sure that your graph here, your y-axis, whatever your y-axis here, has to cross at negative 30 here, or whatever that is, because that's the way this is set with the negative 30 there. All right, let's go to problem number 11. Problem number 11 says find all the real zeros of the function using the quadratic formula or factoring. And so we have x to the 4th, x to the 3rd, x to the 2nd. So I'm going to factor because there's an x squared in each of these. So x squared comes out of this function. We're looking at where it's 0 because we're looking for the zeros. So if I take out x to the 2nd, I get x to the 2nd for the first term, x to this term, and a 20 in the final term. So this has 2 zeros. Actually, it's the same 0 twice. So x squared equals 0. That means x has to be 0, and it has multiplicity 2 because there's 2 of them. There's squared. Okay, now this one we would need to set x squared minus x minus 20 equal to 0. And this one's not too hard to factor because there are certain factors of 20, negative 20, that add up to negative 1. We wanted to add to negative 1 because that's what this is. So I would think they're 5 and 4 because those are 1 apart. We wanted to add to negative 1, so this is going to be negative 5. because those add up to -1 and they multiply together to give you -20. So -5 and +4 would be my factors. So in this case, x equals 5. So x minus 5 equals 0. So that's a factor. And x plus 4 equals 0. So x equals -4. These are multiplicity 1 because there aren't any squares on this. So basically you have 4 zeros. 0 is a 0 twice, and 5 is a 0 once, and -4 is a 0 once. Okay. Number 10. Let's look at what number 10 says. Actually, it's number 12. Form a polynomial whose zeros are given. This is number 12. Sorry, it looks like a 10. It's a 12. All right. So if they give you the zeros, you have to create binomials for those zeros. So this one, when I create the binomials for that, it would be x plus 3, because that gives me -3 as a 0. If I plug in -3 to that, then we have that. X minus 0 and x minus 4. Okay, each one of these has a 0. Now, this is going to, when you multiply together, it's going to give you degree 3 because you have x times x times x. That's x to the 3rd power. So we're okay there. If it has a degree like 4, we'd have to use one of these twice. Some of these might have a multiplicity to them. So this is our polynomial function that we would need to multiply out. So what I would do is this is just x, so I'd write it as x times x plus 3 times x minus 4. And then I would do FOIL on this, get x squared minus 4x plus 3x minus 12, and then multiply that by x. Simplify this into -1x. So we would then multiply and get x to the 3rd minus x squared minus 12x. And this would be our polynomial function for 43. 44 or 45, you would use the zeros of -4, so that would be x plus 4, x plus 1 for the 0 of -1, the 0 of 2 would be x minus 2, and then x minus 3. So we would need to multiply this out to get our polynomial function for 45. And this would have a degree of 4, so we're good here, degree of 4. There are 4 x's multiplied together, we're going to get a degree of 4. So what I would probably do is multiply these out in pairs, and then multiply that together afterwards. So this would be x squared, outside is x, inside is 4x, so that's 5x. And last two are 4. And then this pair is going to be x squared, outside is -3, -2 would be -5x, and then +6. So then I would do a large amount of multiplication to get this. So I got to multiply this times everything in there. So the first 2 is x to the 4th. X squared times that is going to be -5x to the 3rd. X squared to the 6 is 6x squared. Now I'll go to this term, 5x x to the 3rd for this times this. And 5x times 5x, or -5x, is -25x squared. And 5x times that 6 is 30x. And then I have to go to the 4x squared. Positive. 4 minus 20x plus 24. And then I need to combine all my like terms to get my answer. So it'd be x to the 4th. I have an x to the 3rd here. That's going to cross out with this x to the 3rd because they're opposites. So there are no x to the 3rds. X squareds, I have 6, 10, and -25. I'm sorry, 6 plus 4 is 10. Minus 25 is -15x to the 2nd power. So that takes care of all the x squareds. Now the x's, I have 30 and negative 20, so I'm going to have 10x